Well, we are continuing with the concepts of work, power, and energy, and our today's discussion will be on power. So, when we speak power, we are referring to mechanical power, the electrical power, the nuclear power, the various types of power, but the definition remains the same. So, power is mainly concerned with the rate of doing work or the rate of consumption of energy. So we can estimate power by using a composition P is equal to W over T or P is equal to E over T, where E is the energy and W is the work. Therefore, we can say that power is work over time or energy over time. And further, work can be written as force into displacement divided by time. Displacement over time will be velocity. So power can also be estimated by a function that is force multiplied by velocity. Now another thing important about the power is its unit will be joule per second or it will be Newton, and for velocity it is meter per second, so it is Newton meter per second. Now we come towards the main context. The time rate of doing work is called power. The practical unit of power is mainly horsepower, and 1 horsepower is equivalent to 746 watts. Now, concept B will be, that is, power is the rate at which applied force transfers energy, and average power is W over delta T. Delta T is a small time, where W is the work done in delta T time. Instantaneous power can be given as derivative of work with respect to time. So P is equal to dW over dt. Its value may change with time. Now another thing regarding the power, as I have cleared you earlier, that is rate of doing work dW over dt, or it is F multiplied by dx over dt, where dx over dt represents the displacement, rate of displacement, and rate of displacement will be velocity. So, in translational motion, instantaneous power is given by the product of the dot product of force and velocity. Now, power is a scalar quantity. It has only magnitude and no direction, and its unit is joule per second or it is watt. The higher multiple will be 1 kilowatt, that is equal to 10 to the power 3 watts, and horsepower is 746 watts. Engineering unit is generally horsepower. CGS unit is erg per second. So basically we are using in this particular units, that is power is work over time, and then we compute the units of work and the units of time. Then we have to go through with its dimension. So for dimension, power is W over T. For W, we will compute the dimension, and then for T, and then we evaluate the dimension. So the dimension is given as M1 L2 T minus 3. Now we have to apply the concept of power in some calculations. The very first question is, a pump can lift 9,000 kilograms coal per hour. So in this line it is mentioned that the mass is 9,000 kilogram and the time is 1 hour. 1 hour is equivalent to 3,600 seconds. So our question is that a pump can lift 9,000 kilograms coal per hour from a mine of depth 120 meters. Assuming its efficiency to be 75%, its power will be in watts. We want to estimate 75% efficiency means 75 over 100, and that will be equal to 3 over 4. So in order to start with the solution, we first of all apply the formula power is equal to work over time. Then efficiency of pump will be the output over input, and it is multiplied by 3 over 4. So we can write it as output power over P. So P can be given by function 4 by 3 mgh over T, where mgh is the potential energy at height 120 meters. So what we have done, efficiency of pump we have written, efficiency is output by input, and it is multiplied by 3 by 4. So output power divided by P, that is equal to efficiency of pump. So we will make the subject of equation P, which is 4 over 3 mgh over 2 T. And then we compute the values, and the calculated value is found to be 3920 watts. Now, in our next question, what we find is a person of mass 60 kg is capable of taking 15 kilogram object to a height of 10 meters in 3 minutes. We have to estimate the efficiency of the person. So, the given data will be mass is 60 kilogram, that is the mass of a person, and he is holding a mass of 15 kilograms. So what we find is that the total mass holding is 75. So object to the height of 10 meters, height is given and time is given 3 minutes, which is to be converted to seconds. So 3 multiplied by 60, it will be 180 seconds. So what exactly we are doing in order to estimate efficiency? We have to use a formula. Neta is equal to work output over work input multiplied by 100. We multiply by 100 because we have to estimate the percentage. So work output is mgh divided by work input, that is the total mass m plus n, and multiplied by gh into 100. Now when we speak mgh, so it is m over what we have to do, gh will cancel off, and our net result will be m over m plus m multiplied by 100. For small m, we put 15, and for capital M, we put 60. So 60 is the mass of a man and 15 is the mass he is holding while going up. So after all calculations, the result comes to be 20%. So efficiency is 20%. Now in the next question, it is an automobile of mass m accelerates from rest. So when we say automobile of mass m accelerates from rest, that tends to that initial velocity is 0 and m is the mass of the automobile. If the engine supplies the constant power P, then find the equation of velocity and displacement as function of time. So now we have to find the velocity, equation of velocity and the displacement as a function of time. So we know that velocity is given by dx over dt and displacement, that is simply s. So in order to solve this question, we know that power is the product of force and velocity. So in the first line, we have just mentioned F is equal to P. And according to question, P is constant. So now we can write like force is mass into acceleration. So in the next step, we have written mass, and for acceleration, we have written dv over dt multiplied by v, and this is equal to P. Now, F is known to us, mass into acceleration. So, m written as it is and acceleration is written as dv over dt, that is rate of change of velocity with respect to time. Now, what we do is, we have to integrate the function. That is, first of all, what we will do is that m dv over dt is equal to v is equal to p, that can be written as p dt. So, it is p over m dt. And towards the left side, we have to write that is dvv. Now we integrate the function, it is v dv is equal to integration p over m dt. So when we integrate v, it means we are integrating v to the power 1, which is v square over 2, that is shown in the right side. So integration of v dv is given as v square over 2, and integration of p over m dt means that p over m is taken out the integration sign, and then we have to integrate 1 with respect to t. So it is v square over 2 will be equal to p over m multiplied by t, and c1 is called the integration constant. Now as initially the body is at rest, that is v is equal to 0 at t0. So body at rest means initial velocity is 0 at t0. So c1 is equal to 0. If c1 is 0, then we can mention that v square over 2 must be equal to p over m multiplied t. So from this we will make the subject of equation v. So what we will find, v square will be 2pt over m, and then we take square root, that is v is equal to under root 2pt over m. by definition, V is given as ds over dt. So for V, we will write now ds over dt, and that is 2 pt over m square root. Now what we do is dt is taken to the other side in the numerator, and the function can be mentioned as ds is equal to 2 pt over m, and that is power 1 by 2 into dt. And then we integrate the function. So integrate ds and integrate 2 pt over m power 1 by 2. So when we integrate ds means it is 1 ds, and that is equal to s. So by integrating the function, we will come to the conclusion that is s equals to 2p over m multiplied over power half into 2 by 3 d to the power 3 by 2 plus c2. So by computing t as 0, s as 0 and c2 as 0, we come to the conclusion that s is equal to 8p over 9 m to the power 1 by 2, or you can put under root mark, and that is into t power 3 by 2.